Now that we know that every object has both a wave nature as well as a particle nature, how do we mathematically describe both natures in terms of one quantity? If I ask you to describe a particle, you will tell me it has mass m and velocity v. If I ask you to describe a wave, you will probably give me an equation in terms of its amplitude, frequency and phase. But is it possible to describe in terms of one entity both the wave nature as well as the particle nature? How do we do that? By using something called a wave packet. So what we do is we add up waves of different wavelengths and phases, and when you superimpose all of them you get a wave, again another wave. So when you're taking multiple waves and you're superimposing them, you'll again get only one wave. But what's special about this wave is that this wave will have non-zero amplitude only in a certain location, and everywhere else the amplitude will be zero, and that certain location represents the position of the particle. So basically, let's say you're taking an entity, probably a box. Now we all know that the box is made up of atoms, right? And the atoms have electrons in them. So for each electron there will be one wave according to the wave nature. So you take all those waves and you superimpose them, and then you get one big wave called the wave packet. So that wave packet, like any other, the wave packet is also just one wave. It is called a packet because it's a superimposition of multiple waves. Now this packet will, what's special about this packet is that it has a non-zero amplitude only at a certain location. If you look at these individual waves throughout the spectrum, they have mostly these two, throughout the spectrum they have non-zero amplitude. This one, there are certain locations where the amplitude touches zero, but there are multiple locations where the amplitude is non-zero. But the superimposition is such that there will only be one neighborhood where the amplitude is non-zero, and everywhere else it is zero. And this neighborhood represents the location of the particle in space. So you're taking waves and superimposing them, so the wave nature remains intact, but you're also able to describe the particle nature in terms of a wave. So both the characteristics of the entity are being described in terms of one quantity. That quantity is called the wave packet.